Hi guys, in this video we'll be trying to solve this problem on Geeks for Geeks. It's called climbing stairs to reach at the top problem. Essentially this is very similar to the Fibonacci problem. So first let's go through the problem. So there are n stairs. A person standing at the bottom wants to climb the stairs to reach the nth stair. The person can climb either one stair or two stairs at a time. The task is to count the number of ways that a person can reach at the top. Okay. I will share the link to this problem in the description. You can go and look at the solutions that Geeks for Geeks has provided. But let's try to solve it first. Okay. Now let us consider the problem statement. So for example, if there are three stairs and a person is trying to climb up, the ways that he can climb up is one stair at a time. This is the first way to do it, one at a time. So it will be and one stair, and then he reaches the second stair, and then he reaches the third stair, and that is at the top. The second way to climb up the stairs would be he climbs two steps at once and then a single step. So from the problem statement, it is clear that the person can only climb either one step at a time or two steps at a time. If this condition was not given, then there would be another possibility that he could directly jump to the third step, but that is not the case here. Then the last way that he can climb up would be first he climbs one step and then he climbs two steps. That would be the third possibility. One step and then two steps. Similarly, let's write for the second possibility as well, which was two steps and then one step. Okay, I hope the problem is clear. So if it's not clear, you can look at the example that Geeks for Geeks has provided. Okay, so now if you look at it, if there is only one step that you have to climb, there is only one step that you have to climb, then there is only one way to do it. But if there are two steps, then there is either one step at a time or two steps at a time. So there are two ways to do it. But the moment we move to three steps, right? Three steps, nothing looks like it's just a sum of one step plus two steps. So if you look at this much is the single step part. This is one step, and then we do the two step part. So climbing three steps is nothing but the sum of climbing two steps plus climbing one step. As I explained in the last video, if we want to define this static and dynamic way, in a static and dynamic way, then we can say that these two conditions are static conditions. That is, if there is only one step, it is always going to be one way. If there are two steps, it's always going to be two ways. But the moment we move to more than two steps, we can calculate this dynamically using the basic structure that is for one step and for two steps, right? Okay, so let's try to frame the formula. So if we consider this as n, this is nothing but f of n is nothing but f of n minus 1 plus f of n minus 2. So whenever we try to solve a recursive problem, the most basic thing that we should identify is the base case or the exit statement, that as I've explained in the previous video. So the three important things in any recursive function. The first one would be the exit scenario or the base case. The second one would be the recursive call, and the third one would be the calculation. So looking at the setup, we identified the exit scenarios, that is for one step and for two step. Now let us see which will be the recursive case. The recursive case will be nothing but these individual functions that we call. Similarly, the last step is to do the calculation, which is the whole thing here. Yeah. So since we have the formula, it is the same as Fibonacci series. There is no change that we can see here. Let's try to write this code in Python and run it in a environment. Okay. Let's call this stairs, and n will be our input. The first thing that we would do is, okay, so the only difference here that you will see is in the base case. So in Fibonacci series, the base case was f of 0 equals 0 and f of 1 equals 1. Here, however, we will not have a base case for f of 0. We will have the base case as f of 1 will be 1 and f of 2 will be 2, right? So suppose you want to calculate for f of 4. So here what you will do is, the first thing will be, you'll calculate for f of 3, that is n minus 1, and then you would calculate for f of 2. Sorry, f of n minus 2, 4 minus 2, right, 2, right? This will be further splitted into f of n minus 1, that is 2, and f of n minus 2, that is 1. This is not required to be splitted further, because f of 2 we already have the value equals to 2 and f of 1 is already 1. So this becomes 1, this becomes 2. These both are fed back into 3, f of 3. So this essentially becomes 1 plus 2, that is 3. 3 is then fed back to 4. Here f of 2 we already know the value, that is 2. So this 2 is already it's fed back to f of 4. So we need to sum these both up. 3 plus 2, 5. So there are 5 ways to climb the stairs when we have 4 stairs. Okay, let us try to understand f of 4 with the help of a diagram. Let me color code it so that it's easier to understand. Okay, these are the 4 steps. The first way is the most simple way, that is one step at a time. Then the second way would be 2 steps at a time. Then let's do the third way, which would be 2 steps and then 1 step. And then 1 step again. And then the fourth way, which would be 1 step, and then 2 steps and then 1 step. 1 step, 2 steps and then 1 step. This is the fourth way. And now we'll need to find the fifth way. So that would be, the fifth way would be 1 step, 1 step and then 2 steps. So that is 1 step, 1 step and then 2 steps. Yeah, I think we have covered all the cases here. So let's do the exit scenarios first. If n equals 1 or n equals 2, then we would return n. As I have mentioned here, if f of 1 is 1, then it's 1, and if f of 2 is 2, then it is 2. Then the next would be the recursive call. Recursive call 1 equals stairs of n minus 1. Similarly, recursive call 2 equals stairs of n minus 2. And then the last step would be to do the calculation, which is recursive call 1 plus recursive call 2. And then we return that calculation. Let's try for 4. Right, our expected output should be 5, as we have calculated manually. Yeah, that's right, it's 5. Let's try for 10. It's 89. Cool. So this recursive solution to a problem may not always be the best solution, because for example in this problem itself, if you try to calculate for a higher number, you will end up with a TLE, that is time limit exceeded. Let's wait for some time. It should throw that error. Yeah, it says time limit exceeded. However, this problem can be solved by using a hash table. Okay, I will give you a brief about how hash maps would work. Let's not go into detail, but I would like to show you how we can avoid this time limit exceeded issue. So let's create a hash map, call it an empty dictionary. Okay. So, um, how exactly hash map works is, if we are trying to calculate stairs of 5, but while calculating stairs of 5 in the process, it has already calculated stairs of 1, stairs of 2, stairs of 3. Alright. Then when it goes to calculate stairs of 4, it need not necessarily recalculate stairs of 1, 2 and 3, because we are essentially storing the computations that we did for f of 1, 2 and 3 in an hash map. So it will directly fetch it from the hash map. Okay, so let's try to implement that here. If we have this key of n in our hash map, we would like to return the value to it, that is hash map of n. Else, we would like to add it to our hash map. So you do hash map of n equals recursive call 1, that is stairs of n minus 1 plus stairs of n minus 2. Or this can also be written, if you want to follow the same coding pattern, this way. Okay. Now when we run this gives us the value. If there are 44 stairs, there are these many ways to climb up the stairs. Don't worry if you have not understood the hash map concept. When we will get to the hash map videos, I will explain it to you in much better detailed format. Thank you for watching, guys. See you in the next one.